Welcome back. Today we are going to study about quadrilaterals. What are quadrilaterals? A quadrilateral is a polygon and it is a four-sided polygon. What is a polygon? Let us recall. A polygon is a simple closed figure made up of straight line segments. Made up of straight line segments. So, starting with the smallest polygon, we have triangles, a three-sided figure, then we have a four-sided figure, quadrilaterals. So, today we will be studying about quadrilaterals in detail. What will we be studying in the chapter of quadrilaterals? We will be studying the definition of quadrilateral. How is a quadrilateral defined? That we have already done. It is a four-sided polygon. Then the parts of a quadrilateral. A quadrilateral is made up of what and what it includes. Next, we will be studying about the angle sum property of a quadrilateral, which defines that what will be the sum of angles made by all the interior angles of a polygon. Types of quadrilaterals, because a four-sided figure may have different shapes. Then we will be studying properties of parallelogram, and last but the most important concept, the midpoint theorem. Starting with the definition of a quadrilateral, as I said, a quadrilateral is a four-sided polygon. It is a four-sided polygon. How it is formed? We know a line is formed by joining collinear points. Collinear points, that means all the points lying on a straight line, if I connect them, I will get a straight line. And we also know that through one point, infinite number of lines can pass, but if I have more than one point, only one straight line can pass through it. A triangle is formed. How is a triangle formed? When out of 3 points, no 2 of them are collinear. So, 3 out of 4 points are non-collinear, then a triangle will be formed. Out of 4 points, if 3 are collinear and the fourth one is non-collinear, then a triangle can be formed. If 4 of them are collinear, then a triangle will not be formed. So, gradually moving to a quadrilateral. How is a quadrilateral formed? When out of all the 4 points, only 2 of them are collinear. Like if A and B are collinear, but D is not collinear with A and B, and C is not collinear with A and B, then a quadrilateral will form. So, if no 3 points are collinear, like A, B and C, they are not collinear, although 2 points are collinear, then a quadrilateral can be formed. Next, let us define a quadrilateral properly. So, what did we see? That a figure formed by joining 4 points in order. In order means in a proper order. We cannot go in a haphazard way. See, let us see what is the order. If I have points A, B, C and D, then either I have to connect these points in clockwise or in anti-clockwise direction. So, if I connect the point in the anti-clockwise direction, I can see a quadrilateral is formed, and we name the quadrilateral also in the same way. I will name it as ABCD or DABC or CDAB or BADC. So, let us see what are the different names which I can give to the quadrilateral. Starting from A, in anti-clockwise direction, ABCD, I can name a quadrilateral like this. Starting from A, in the clockwise direction, I can name it ADCB. Similarly, I can start from any point, but I have to choose a particular direction, either clockwise or anti-clockwise, to name a quadrilateral. I cannot name it as ACBD or ADBC. I cannot go in a zigzag way. I have to take a proper path, either clockwise or anti-clockwise. Then let us study about parts of quadrilateral. We have discussed that how is a quadrilateral formed by joining 4 line segments. As we join 4 line segments AB, BC, CD and DA, these are the 4 sides of a quadrilateral, the integral part of it. Now, how did we start connecting the line segments? By the points. I started with the points A, B, C, D. These points are known as the vertices of the quadrilateral. When 2 line segments meet, like here AB and BC, when they meet, and BC and CD, they meet at point C, and CD and DA, they meet at point D, AB and DA, they meet and when 2 line segments meet, an angle is formed. Let us see how are the angles formed. If I have line AD and line BA, when AD is connected with BA, when they meet, angle A is formed. When DC and BC meet, angle C is formed. Similarly, angle D and angle B is formed. So, since there are 4 vertices and 4 sides, 4 angles will be formed. When I connect these opposite vertices, A and B, they are adjacent vertices lying on the same straight line segment. But if I am talking about B and D, they are not lying on the same side of the quadrilateral. So, we call them opposite vertices. When the 2 opposite vertices are joined, the diagonal of the quadrilateral is formed. But when the 2 adjacent vertices are joined, then side of the quadrilateral is formed. So, we can see a quadrilateral has 2 diagonals because we have 2 pair of opposite vertices, vertices B and D and A and C. So, these are the 2 diagonals formed by joining opposite vertices of the quadrilateral. So, a quadrilateral has how many parts? It has 4 sides, 4 angles, 4 vertices and 2 diagonals. Example of quadrilaterals. We have a general notion that all quadrilaterals are square and rectangles. No, there is a broader classification of it. These are the examples and they all have different shapes. All the shapes are not same. So, depending on this, we have types of quadrilaterals that we will study later. Before we move to types of quadrilaterals, let us study about angle sum property of a quadrilateral. Angle sum property of a quadrilateral tells us about the sum of interior angles of a quadrilateral, and we can verify it using the angle sum property of a triangle, which states that the sum of interior angles of a triangle is 180 degree. So, angle sum property of a triangle states that the sum of angles, sum of the interior angles of a quadrilateral is equal to 360 degree, which means angle A plus angle B plus angle C plus angle D is 360 degree. Let us see how do we verify it or how do we prove it. Suppose we have a quadrilateral ABCD and we divide the quadrilateral into 2 triangles by joining the opposite vertices AC. A and C. So, AC is the diagonal of the quadrilateral which divides the quadrilateral into 2 triangles. Triangle ABC has angles 1, 2 and 3 named, and triangle ADB we have named the angle as 4, 5 and 6. We have numbered the angles. How will I prove it? If I look at triangle ABC, the sum of angles 1, 2 and 3, it adds up to 180 degree. And the sum of angles 4, 5 and 6, they also add up to 180 degree. 180 degree is the sum of the angles of the triangle ABC and 180 degree is the sum of the interior angles of the triangle ADC. So, if I take both the triangles together, 180 plus 180 will give me 360 degree. So, verifying it in a proper way, how do we verify it or prove it? We have to start with joining A and C, that means drawing the diagonal AC. In triangle ABC, angle 1 plus angle 2 plus angle 3 is 180 degree owing to angle sum property of a triangle. And in triangle ACD, angle 4 plus angle 5 plus angle 6 is also 180 degree owing to angle sum property of a triangle. Adding 1 and 2, what do we get? The sum of all angles equal to 360 degrees. if I group angle 1 and angle 4, I'll get angle A. If I group angle 3 and angle 6, I'll get angle C, angle B and angle D. So, if I make pairs, I can make pairs owing to the commutative property of addition. That means, if I change the order of the numbers, the sum would remain same. So, hence we can see that angle A plus angle B plus angle C plus angle D equal to 360 degree. Now, next, as I told you, we will be studying about types of quadrilaterals. Not all quadrilaterals are square and rectangles. There is a much broader classification. What is the classification? Broadly, the quadrilaterals can be divided into 3 types. The first is a parallelogram, the second is a trapezium, and the third is a kite. What is the basic difference between the 3? A parallelogram has 2 pair of sides parallel and equal. So, we have 2 pair of parallel sides in a parallelogram. In trapezium, we have only 1 pair of sides as parallel. In kite, we do not have any pair of parallel side. So, the parallel sides, the number of parallel sides, they distinguish one type of quadrilateral with the other. Under parallelogram, we have other classifications. The first type of parallelogram is a rectangle, the second is a square, and the third is a rhombus. So, we can see the broad classifications. Broadly, the quadrilateral is divided into 3 broad classifications: parallelogram, trapezium and kite, which are different because of the pair of parallel lines in them. A parallelogram has 2 pair of parallel sides, trapezium has only 1 pair of parallel sides and kite has none. These are the examples of parallelogram. A rectangle is a parallelogram because it has 2 pair of parallel sides. Square has 2 pair of parallel sides. Rhombus also has 2 pair of parallel sides. Apart from this, there are other properties of rectangle, square and rhombus and parallelogram as the whole. Let us study about parallelogram in detail. As we started, the sides opposite are parallel to each other. As such, we have 2 pair of parallel sides. AB and CD, which are the opposite sides, are parallel to each other. AD and BC, which are yet another pair of sides, opposite sides, they are also parallel to each other. They are not only parallel but equal to each other. So, AD is parallel to DC and AB is equal to DC. Also, AD is parallel to BC and AD is equal to BC. We can also see the pair of opposite angles are equal. A will be equal to C and angle D will be equal to angle B. Further, if I connect the opposite vertices, we get the diagonals of a parallelogram. AC and BD, they are the 2 diagonals, and if I connect the 2 diagonals, they intersect at point O. They intersect at point O in such a way that each diagonal is bisected. That means AO becomes equal to OC and OB becomes equal to OD. Also, the sum of adjacent angles, we have already stated that the opposite angles are equal, and the sum of adjacent angles, the adjacent angles are angle A, angle D. Adjacent angles are those which are lying on the same straight line or the same side of the parallelogram. The sum of adjacent angle is 180 degree. Angle A plus angle D will be same as angle D plus angle C, will be same as angle C plus angle B, will be same as angle B plus angle A equal to 180 degree. So, let us quickly summarize all these. Opposite sides of a parallelogram are equal and parallel. Diagonals bisect each other. That means each diagonal is divided into its half. Opposite angles are equal and the sum of the adjacent angle is 180 degree. So, if a quadrilateral satisfies all these properties, it becomes a parallelogram. We will study more about the properties of parallelogram. These were the basic properties that we have studied. A diagonal of a parallelogram, we know a diagonal of any quadrilateral divides a quadrilateral into two triangles, but the triangles will be congruent only if it is a parallelogram. So, the diagonal of a parallelogram divides it into two congruent triangles. Let us verify. Suppose we have a parallelogram ABCD. The diagonal AC clearly divides the parallelogram into two triangles ABC and ADC. To verify that this diagonal divides the parallelogram into two congruent triangles, let us start with the two triangles. In triangle ADC and triangle ABC, angle 1 is equal to angle 4. We can see angle 1 and angle 4. They are equal. Why? Because CD is parallel to AB, opposite sides of a parallelogram are parallel. As such, CA is the transversal. If CA is the transversal, angle 1 will be equal to angle 4 because they are forming a pair of alternate angles. Similarly, if I take AD and BC to be the parallel sides, then angle 3 will be equal to angle 2, as these two lines are parallel and AC is again the transversal, and as such again 3 and 2 are pair of alternate angles. So, we have proved two pair of angles equal. We can also see AC is a common side to both the triangles. So, using angle side angle criteria, I can clearly prove that these two triangles are congruent, which proves that the diagonal of a parallelogram divides the parallelogram into two congruent triangles. We have done basic properties of parallelogram. Now, let us try to prove those properties. How do we prove that for a parallelogram the opposite angles are equal and the opposite sides are equal and also the diagonals bisect each other? So, studying those properties one by one, if each pair of opposite sides of a quadrilateral is equal, then how can we say that it is a parallelogram? How will I prove the opposite pair of sides parallel? Starting with a parallelogram ABCD, if I start with the parallelogram ABCD, let us connect the diagonal AC. It is given that the opposite sides are equal, which means CD is given to be equal to AB and AD is given equal to BC. If I prove these two triangles congruent, see, every proof of the property of a parallelogram depends on the congruency of the triangle. So, if I can prove that these two triangles are congruent, it can be easily proved that the opposite pair of sides are parallel. Let us see how. In triangle ADC and triangle ABC, AD is equal to BC and AB is equal to DC. Two sides are given to be equal. The third side AC is common to both the triangles. So, by applying SSS congruency rule, we can see that the two triangles are congruent. Once the two triangles are congruent, their corresponding paths will be equal. Let us talk about the corresponding angles. Angle 1 and angle 2, they will be equal because they are corresponding angles. They are the corresponding paths of congruent triangles. And 1 and 2, we can clearly see that they form a pair of alternate angles. And when are the alternate angles equal? The alternate angles are equal only when the lines are parallel. So, this simply proves that these two pair of sides are parallel. Again, angle 3 is a corresponding part to angle 4. They are the corresponding parts of congruent triangle, angle 3 and angle 4. So, they will be equal. Again, angle 3 and angle 4, they form a pair of alternate interior angles when AC is the transversal and these two are the parallel sides. So, we could easily prove that both the pair of equal sides are parallel using the congruency of the two triangles. Let us recap it. We started with quadrilateral ABCD where the two opposite sides are given to be equal. We need to prove that ABCD is a parallelogram. That means we need to prove that the two pair of opposite equal sides are also parallel. Starting with the congruency condition, we could prove both the triangles congruent by SSS. Once the two triangles are proved congruent by SSS, their corresponding paths are equal, and the corresponding paths, we can clearly see the corresponding paths form a pair of alternate interior angles, and once the pair of alternate interior angles are equal, the sides would be parallel, and hence ABCD is proved to be a parallelogram. Next, in a parallelogram, opposite angles are equal. Let us see how can we prove this. This can be proved again by the congruency of triangles. In a parallelogram, opposite angles are equal, and to start with, we are given with a parallelogram ABCD with diagonal AC and BD. So, starting with diagonal AC, I can prove B and D to be equal. Let us see how. Angle A equal to angle C and angle B equal to angle D. We have to prove that. Starting with diagonal AC, angle 1 will be equal to angle 4 because the opposite pair of sides are parallel and they are alternate interior angles. Similarly, angle 3 and angle 2, they are also equal because they are also pair of alternate interior angles. Now, if I add these two equations, on the left hand side we will get angle 1 plus angle 2, and on the right hand side we will get angle 4 plus angle 3 or angle 3 plus angle 4. If 1 and 2 are added, they form angle C of the parallelogram, and if 3 and 4 are added, they form angle A of the parallelogram. So, we can clearly see that angle A equal to angle C. If I draw another diagonal BD, in the same way we can prove that angle B is equal to angle D. So, it proves that the opposite angles of a parallelogram are equal.
To watch the complete video, download the Upbind educational app from Play Store and App Store.